First hurricane seeding experiment. Published by NOAA, AOML, National Oceanic and Atmospheric Administration. On the afternoon of October 13, 1947, an Air Force B-17 aircraft penetrated a hurricane 415 miles, 667 kilometers, east of Jacksonville and dumped several pounds of crushed dry ice into the storm, just to see what would happen. This was the first attempt to modify a tropical cyclone by seeding it with freezing nuclei. It was almost the last. The previous year, Vincent Schaefer, working at General Electric, GE, laboratories, discovered that by introducing dry ice, solid carbon dioxide, into an environment with supercooled water that was colder than 32 degrees Fahrenheit, 0 degrees Celsius, but had not yet frozen, he could induce the water to freeze into ice. He realized that this could be done in the free atmosphere and could spur microphysical reactions that would alter clouds and precipitation. At his urging, GE Labs reached an agreement with the Naval Research Laboratory and Army Signal Corps, dubbed Project Cirrus, to carry out experiments where Air Force aircraft would seed clouds and fog with dry ice to see what changes occurred. It wasn't long before plans were made to try a seeding experiment in a hurricane. However, it wasn't until late in the following hurricane season that Air Force planes and Navy personnel became available to carry out the mission. On October 12, a hurricane, designated King by the Air Force Hurricane Office, moved northeastward over Florida, dumping tropical downpours on the southern end which caused damaging flooding that persisted for days. The next day the storm moved off the coast and continued out to sea. This seemed an ideal case for Project Cirrus, as the hurricane was no longer interacting with land and should not affect anyone after the experiment. That afternoon, two B-17s and a B-29 left Mobile, Alabama and flew eastward to intercept the hurricane. The first bomber flew at cloud top level and did the seeding. Large chunks of dry ice were fed into a crusher on the plane and dumped from the belly into the clouds below. The second B-17 followed a half-mile behind and 3,000 feet, 900 meters, above to document the cloud changes. The trailing B-26 was the control aircraft and carried Schaefer to monitor the changes and direct the other two planes. The aircraft lacked sophisticated homing gear, so it was decided not to penetrate the eye or heavy rain bands of the hurricane, but seed the outer clouds. They first made a half-hour run over 100 miles, 175 kilometers, long, dumping 80 pounds, 36 kilograms, of ice along the way. They backtracked then to see what the clouds had done. Next they did two mass droppings of 50 pounds, 23 kilograms, each into one large cumulus top and orbited the cloud to see any changes. They noticed that after the first run, the cloud deck below began to break up. After the second test, the cloud top continued to grow. Satisfied with their effort, the airplanes returned to base. The scientists were eager to examine the storm the following day. However, when they flew to the predicted storm location, they had trouble locating the eye. After some hunting around, they found the hurricane center nearly 100 miles, 160 kilometers, west of where they expected it to be. To their astonishment, the hurricane had made a 135-degree left turn and was now moving due west. On top of that, it was strengthening. By the afternoon of the 15th, Hurricane King struck Savannah, Georgia. One person died in the storm surge and $2 million in damage was done to Georgia and South Carolina. The public was outraged that the scientists had caused the storm to swerve into Georgia and threats of lawsuits were thrown about. GE's case was not helped when the head of its laboratories, Dr. Irving Langmuir, issued a statement that he was 99% sure the storm had changed course due to the seeding. Chief of the Weather Bureau, Dr. Francis Reichelderfer, thought differently and appointed 3 of his weathermen to find a case where a hurricane had followed a similar track but had not been seeded. The case was published, demonstrating that hurricanes could swerve like that without the use of dry ice, and the threats of lawsuits eventually evaporated. But the public's early enthusiasm for weather modification slackened. In an era when many science fiction movies featured mad scientists threatening world destruction, or worse, from their hubris, this event seemed to fit the trope. For many years after, no scientist dared mention weather modification and hurricane in the same sentence. 11 years later, the National Hurricane Research Project carried out very modest seeding equipment tests in a hurricane, but kept things on the down low until they were sure the storm wasn't going to pull a swerve on them. It wasn't until 1962 that the U.S. Weather Bureau and Department of Defense reached a formal agreement to carry out Project Stormfury and attempted to seed hurricanes again. It was an ambitious experimental program of research on hurricane modification carried out between 1962 and 1983. The proposed modification technique involved artificial stimulation of convection outside the eye wall through seeding with silver iodide. The invigorated convection, it was argued, would compete with the original eye wall, led to the reformation of the eye wall at larger radius, and thus, through partial conservation of angular momentum, produce a decrease in the strongest winds. Since a hurricane's destructive potential increases rapidly as its strongest winds become stronger, a reduction as small as 10% would have been worthwhile. Modification was attempted in 4 hurricanes on 8 different days. On 4 of these days, the winds decreased by between 10 and 30%. The lack of response on the other days was interpreted to be the result of faulty execution of the seeding or of poorly selected subjects. These promising results came into question in the mid-1980s because observations in unmodified hurricanes indicated 1. That cloud seeding had little prospect of success because hurricanes contained too much natural ice and too little supercooled water. 2. That the positive results inferred from the seeding experiments in the 1960s stemmed from inability to discriminate between the expected results of human intervention and the natural behavior of hurricanes. For a couple decades, NOAA and its predecessor tried to weaken hurricanes by dropping silver iodide, a substance that serves as an effective ice nuclei, into the rainbands of the storms. During the Stormfury years, scientists seeded clouds in hurricanes Esther, 1961, Beulah, 1963, Debby, 1969, and Ginger, 1971. The experiments took place over the open Atlantic far from land. The Stormfury seeding targeted convective clouds just outside the hurricane's eye wall in an attempt to form a new ring of clouds that, hopefully, would compete with the natural circulation of the storm and weaken it. The idea was that the silver iodide would enhance the thunderstorms of a rainband by causing the supercooled water to freeze, thus liberating the latent heat of fusion and helping a rainband to grow at the expense of the eye wall. With a weakened convergence to the eye wall, the strong inner core winds would also weaken quite a bit. For cloud seeding to be successful, the clouds must contain sufficient supercooled water, water that has remained liquid at temperatures below the freezing point, 0 degrees Celsius, 32 degrees Fahrenheit. Neat idea, but in the end it had a fatal flaw. Observations made in the 1980s showed that most hurricanes don't have enough supercooled water for Stormfury seeding to work. The buoyancy in hurricane convection is fairly small and the updrafts correspondingly small compared to the type 1 would observe in mid-latitude continental super or multicells. In addition, it was found that unseeded hurricanes form natural outer eye walls just as the Stormfury scientists expected seeded ones to do. This phenomenon makes it almost impossible to separate the effect, if any, of seeding from natural changes. The few times that they did seed and saw a reduction in intensity was undoubtedly due to what is now called concentric eye wall cycles. Thus nature accomplishes what NOAA had hoped to do artificially. No wonder the first few experiments were thought to be successes. Because the results of seeding experiments were so inconclusive, Stormfury was discontinued. The primary focus of NOAA's Hurricane Research Division today is better physical understanding of hurricanes and improvement of forecasts. The best way to minimize the damage of hurricanes is to learn to coexist with them. Proper building codes and understanding the assumption of risk by choosing to live in a hurricane-prone area can help people evaluate their situation. Smart hurricane prep and public education, along with improved forecasting, can help when a hurricane inevitably makes landfall. For more information about hurricane mitigation efforts, visit our Hurricane FAQ. Barrington S. Havens, History of Project Cirrus Report Number RL 756, Schenectady, New York, Research Publication Services, July 1952, page 62 to 63. Conrad Mook, Eugene Hoover, and Robert Hoover, An Analysis of the Movement of a Hurricane off the East Coast of the United States, October 12 to 14, 1947, Monthly Weather Review, July 1957, 243 to 250. Hugh E. Willoughby, David P. Jorgensen, Robert A. Black, and Stanley L. Rosenthal, Project Stormfury.